Hello everyone. Let's take a look at question 4 from this June exam. Trolley A of mass 1.5 kilograms is at rest on a frictionless horizontal surface. So I'm going to put V is equal to 0. A second trolley B of mass 2 kilograms traveling horizontally at a constant speed V collides with trolley A. The trolleys stick together and move at a constant velocity to the right, covering a distance of 0.8 meters in 2 seconds. See the diagram below. Ignore all frictional and rotational effects. 4.1 we'll leave out. We'll go straight to 4.2. Calculate the speed v with which trolley B moves before the collision. So we can use the conservation of linear momentum in this question. So 4.2, we will write that the sum of the momentum before is equal to the sum of the momentum after. So before the collision and then after the collision. Now, momentum is calculated by saying the mass times the velocity. So we're going to say the mass of B is 2 times its velocity is V plus the mass of A is 1.5, its velocity is 0, and that's equal to, after the collision, both of them are joined or they're attached to each other, so we can add the masses up. So the masses is going to be 2 plus 1.5. And the velocity, they tell us it's a constant velocity, and they tell us that the distance, or it covers a distance of 0.8 meters in 2 seconds. So we can calculate the speed here. So v is equal to distance over time. And we can use this because it's constant. So 0.8 divided by 2, that's 0.4 meters per second. And we can substitute that there. And so now our only unknown is v. So I can solve for v. And, oh, I forgot. We need to choose a direction as positive. I'm choosing right as positive. And so v is then equal to, I think it's 0.7 meters per second. And since it's positive, it's moving to the right. Okay. Well, they asked for speed, so we don't need to give direction. Actually, yeah. So speed, remember speed is a vector, scalar quantity, sorry. So you don't need to give a direction. So we don't even have to include that. Question 4.3. Is the collision elastic or inelastic? So remember, if a collision is elastic, it means that the kinetic energy is the same, conserved. If it's inelastic, it means it's not conserved. Now, there's actually two ways you could do this. The first way is just you could remember that if there's a collision between two objects and one is stuck to the other afterward, then that's going to result in an inelastic collision. So 1 mark, so obviously no calculation necessary. Though if that's something that you don't or you didn't remember, you can of course go and calculate it because we have enough information. We can do it, I'll show it to you. You can say that the kinetic energy before, right? So the kinetic energy of B and the kinetic energy of A. So A is stationary beforehand, so it has no kinetic energy. B, we can calculate the kinetic energy. That's going to be half m and then v squared, so 0.7 squared, and that's 0.49 joules. So then the total before is going to be 0.49 plus 0, which is 0.49. Then after, so the EK after, A and B are joined, so it's just going to be EK is equal to 2 plus 1.5 is 3.5, and well, half of that multiplied by the velocity, which we worked out to be 0.4 squared, and I have that worked out as 0.28 joules. And so you can see that it's not the same, so inelastic. And then moving on to the last question here. Question 4.4. During another collision, trolley B exerts a greater force on A and the change in momentum is the same. So delta P is constant. F net is increased. And they want to know how is the time affected. So they want to know time. So choose from increase, decrease, or remain the same. So this one, we can use the formula F net is equal to delta P divided by delta T. So if F net increased, the time would have decreased, because F net is inversely proportional to time. So if the F net increased, the time would have decreased. And this is one of the questions that's usually asked when they ask you to explain like why you bend your knees when you fall, or why is there a crumple zone for cars, and so on and so forth. And that's it, 10 marks. Not too bad, I would say. Thanks so much for watching. I'll see you in the next video.